Solve the following logarithmic equation. Log base 2 of x plus log base 2 of x plus 2 equals 3. So in this situation, we have the argument of a logarithm that is a variable. And whenever you have a variable in the argument of a logarithm, you're probably not going to be able to solve it in logarithmic form. So what we would need to be able to do is change it into exponential form in order to continue solving. In order to do that, we just have to have one logarithm equal to a constant. So we're going to have to do some work first to get to that point. But what's nice is we have two logarithms that are added. And since they are the same base, we're actually able to combine those into a single logarithm where the arguments are multiplied. Now we have one logarithm equal to a constant, and we can change that into from log form into exponential form. And then hopefully at that point we'll be able to continue solving. So in exponential form, the base of my exponential equation will be 2 because that's the base of the logarithm. And the result of a logarithm is the exponent, so that's going to be 2 to the third power. And then the result here is the argument of the logarithm, so x times the quantity x plus 2. All right, now we haven't solved the equation at this point, but we're certainly much closer. The next thing that we need to do is start simplifying things. 2 to the third is 8, and this x can distribute into this set of parentheses, giving x times x is x squared, x times 2 is 2x. So because of this squared value, so the largest exponent is 2, that means we have a quadratic. To solve any quadratic, what we need to do is we need to bring everything to one side of the equation. So I'll just subtract 8 from both sides to get rid of it on the left-hand side. And then we'll try to factor if possible. If it won't factor, then we can use other means of solving the quadratic. But I think this will factor. So x and x will multiply to x squared. 4 and 2 will certainly multiply to 8, but I need this to add these two constants to add up to positive 2, so I need this to be a positive 4 and a negative 2 for that to work out. Now, when I set each of these factors equal to 0, x minus 2 equals 0, then I get x equals negative 4 and x equals positive 2 as potential solutions. Now, the reason that these are only potential solutions is because anytime you have a value that would lead to the negative logarithm, that needs to be excluded from the solutions because that's what we call an extraneous root. So it's a solution to an equation that's introduced through the process of solving. So to check these out, all we need to do is just take these values, so x equals negative 4, and then just plug them into the original logarithms. So on the first one, I would have log base 2 of negative 4, which isn't allowed. We can't take the logarithm of a negative number. The other one would be log base 2 of negative 4 plus 2. That would also be negative, but it doesn't matter if one or both result with a negative. If either of them do, then we have to throw that out as our solution. So then positive 2, let's see what happens there. If I put positive 2 in, it would be log base 2 of 2, because I'm just replacing x with 2, so that's fine. And log base 2 of 2 plus 2, which is 4. So that's a positive number, and that's fine as well. So x equals 2 is a valid solution, but x equals negative 4 is not. So we have to throw that out.